Have you ever looked at a piece of software and just wondered how it all works? It can seem like this incredibly complex, maybe even magical thing. But here's the secret. It all boils down to just a few core ideas. Today, we're going to pull back that curtain and break programming down into its essential, understandable parts.
So, let's kick things off with the big question. How in the world do you build a computer program from scratch? Well, you might be surprised, but it has a whole lot in common with a construction project.
I mean, think about it. You wouldn't just start throwing up walls and hope a house appears, right? No way. You start with a blueprint. That plan prevents you from making huge, costly mistakes, and it makes sure you're building something that's stable, organized, and, actually does what you want it to do.
And that brings us to programming's grand blueprint. In the coding world, these are called paradigms. Just like a house can be a super modern high-rise or a classic Victorian, a program can be built using different styles. You could build it by following a very strict sequence of steps, or maybe by modeling real-world objects. They're just different approaches, but they all provide a solid, reliable structure to build on.
And really, that's the whole point of these frameworks. They allow us to create solutions that don't just kind of work, but are actually efficient, reliable, and easy to understand later on.
Okay, so our blueprint is in hand. What's next? Well, you can't build anything without your raw materials and a good set of tools. You never build a house without bricks and a hammer, and it's the exact same idea when you're building a program.
First things first, let's talk about our raw materials. In programming, these are called variables. The best way to think of them is as the bricks, the lumber, and the glass of our digital house. They're the individual pieces of information, like a name, a price, or a score, that we're going to build everything else with.
And these materials, they come in different flavors. You've got your whole numbers, which we call integers. Then there are numbers with decimal points. Those are floating points. You've got text, which programmers call strings, and my personal favorite, Booleans. They're just simple, on or off, true or false switches that basically act as the entire electrical system for your program's logic.
All right, so we've got our piles of digital bricks and lumber. Now we need to actually do something with them. That's where our tools come in. In code, these tools are called operators. They're what let us perform actions on our variables, to combine them, to compare them, to change them. The most basic tools, the ones you'll find in any kit, are the arithmetic operators. And you already know these, for sure. Plus, minus, multiply, divide. These are the absolute hammers and saws of programming, letting us do all the fundamental math with our numbers.
But basic math is just the beginning. The real power, the magic, starts when our code begins to ask questions. Relational operators are like our measuring tape. Is this number bigger than that one? And then Boolean operators let us build some really smart logic. Is this condition and that other condition both true? This is how a program starts to make decisions.
So we've got the blueprint, the materials are on site, and we've got our tools ready to go. Now it's time to lay out the floor plan. This is all about designing the flow of our program, telling the computer exactly what to do and in what order to do it.
This is where something called control structures come in, and they really are the floor plan of our program. Think of them as the hallways, the doorways, and all the different rooms. They direct the traffic, telling the computer which lines of code to run, when it should repeat something, and when it should skip a section entirely.
Now, one of the most powerful structures we have is the loop. A for loop, for example, is like having an automated machine on our construction site. We don't have to say, lay a brick, now lay another brick, now lay another 100 times. We just say, hey, lay 100 bricks. It handles all that repetition for us, which is, as you can imagine, incredibly efficient. So these control structures really give our programs two main superpowers: making decisions and repeating actions. An if-then-else statement is like a fork in the road. The program checks a condition, and if it's raining, it goes one way, if not, it goes the other. A while loop is a different kind of repetition. It creates a cycle that keeps going and going, but only as long as a certain condition stays true. All right, look at that. Our house is really taking shape. We've got a foundation, we've got walls, and we have a basic layout. But let's be honest, a house isn't very useful if everything is just thrown inside in a giant pile. We need organization. We need closets and shelves and filing cabinets. In programming, these closets and shelves are our data structures. They are specialized containers whose only job is to organize and manage our information, so we can find exactly what we need right when we need it, without having to search through the whole house. A really common one is called an array. Just picture a long row of mailboxes at an apartment complex.
where each box has a unique number. It's just a collection of items stored in a very specific order. If you need whatever is in slot number 5, you can go right to it. Super simple and super fast.
But what if you need something a little more flexible? That's where a list comes in handy. Imagine a shopping list where you can just add new items to the bottom, cross things off anywhere you want, or change the order. Lists are dynamic, meaning they can grow and shrink while the program is running, which makes them incredibly useful.
Okay, but what if you want to group different types of information all together? For that, we have something called a record. A record is basically like a business card. It holds a bunch of related but different pieces of data, like a name, a phone number, and a job title, all bundled together in one neat little package.
So, with all our stuff neatly organized in its digital closets, we need some efficient recipes for doing common things. These recipes are called algorithms. They are proven, step-by-step methods for solving problems, like searching for one specific item in a huge collection or sorting 1,000 names alphabetically.
Let's look at 2 really fundamental ways of handling this data flow. First, you have a stack. It works on a last in, first out principle. Think of a stack of cafeteria trays. The last one you put on top is the first one you take off. Then you have a queue, which is the opposite. First in, first out. That's just a regular line, like at the movies. The first person to get in line is the first person to get a ticket. And there you have it. Seriously, from a simple idea, a blueprint, we've now built a complete, organized, and functional structure. Let's just do a quick flyby and look at all the pieces we put together.
So let's just recap. We started with our blueprint, the programming paradigms. Then we gathered our raw materials, which were variables and all their different data types. We used our tools like operators to shape that data. We laid out the floor plan using control structures to direct the flow. And finally, we brought in the organization with data structures and efficient algorithms.
Here's the cool part. You now understand the fundamental building blocks behind all software. From the simplest little app on your phone to the most complex operating systems in the world, they all use these exact same core concepts. So the only question left is, now that you have the blueprint, what will you build?